So, so basically we call this a vertical asymptote. Shaking? Oh, that's weird. We call this a vertical asymptote. No, wait, we don't. We call this a vertical asymptote because it goes up and down. We call this one here a horizontal asymptote. Make sense? Mm-hmm. So horizontal asymptote is the y one. The vertical asymptote is what x can't be. And again, if you're not sure, just pick a couple points on there and say, okay, this is -1, -2. This is -1, 0. Oh, the -1 stays the same. The x stays the same. So x must be -1. Okay. So next page, page 6. Here is an example. The question is, what is the domain and what is the range? Well, what can x not be? What can x not be? Everyone find what x cannot be. Find the domain and range. Write them down. Write them, physically write them down. What can x not be? What can y not be? Domain and range. So my domain is x can't be -1.
What about y?
Right? X cannot be -1. Likewise, y cannot be what? 0. What you'll notice is that the line x equals -1 is the vertical asymptote. So the asymptote is x equals -1. It's the exact same thing as this, only equals, right? So my asymptote is x equals -1. My asymptote for y is y equals 0. So it's kind of, the asymptotes are super easy to find because once you figure out what x can't be, then x equals that line is the line that it can't touch. In other words, what's the line that y can't touch? What can y not be? Y can't be 0, so the line y equals 0 is the line that y can't touch. Think of it like kryptonite, right? It's the one that you can't touch. Okay. Good. So that's makes it super easy. Oops. So the line y equals 0 is the horizontal asymptote. The line x equals 1 is the vertical asymptote. So my asymptote is going to be x equals -1 and y equals 0. So you can see the total direct correlation with those, right? Okay, so now you folks are just going to do some exercises, straightforward, just looking at the graphs. Figure out what the domain and range is for each of these, and what the asymptotes are. The domain, range, asymptotes. So there's 2 on this page, there's 1 on the next page. So the first one is a little more straightforward, right? What can x not be? X can't be 4. Everyone kind of see that one from there, from the picture? Mm-hmm. And my range, y can't be what?
0.
Yep, y can't be 0. So what are my asymptotes then? My asymptotes are x equals 4 and y equals 0. They match up. Right? That's the equation of the asymptote. Y equals 0. This right here is y equals 0. And then x equals 4. That's it. That's this one here. This line here is x equals 4. This line here is x equals 4. Okay, now the one on the right is a little bit stranger. I kind of blacked out what it can't be. But that might be more confusing, maybe, I don't know. Yeah, I'll get rid of that, move it over here. Okay, so what's my domain? What can x not be?
0.
0. X can't be 0. But my y, what's up with the y? So just think of it like regular. What's the lowest y can be? What's the lowest y goes?
-1.
-1. Can it touch -1? No. Is that what I wrote that part? It can't touch -1. What's the highest it can be? What's the highest y goes? Infinity. Thank you. So the y goes from -1 to infinity. So someone said, well, it can't equal, so it can't equal, looks like y can't equal -1. That looks like that might be an asymptote. That seems like an asymptote. Does that make sense for folks?
Mm-hmm.
And the other asymptote looks like it's x equals 0. So this one matches up with that one, and this one matches up with that part. But then y also can't be anything below. So this is just y is, you have to write this as y is greater than -1. Because it's only, it can't be, it's not just -1 it can't be, because it can't be any of this stuff down here either. Does that make sense? So it goes throwing you off, because it's like, yeah, it can't be -1, but it also can't be anything below -1. So when it can't be a whole bunch of stuff, then we say what it can be.
Oh.
So you see what I'm saying? So as we'd say it can't be -1 or below, that's like too many things. So instead we just say it can be -1 and above, but it can't be touched, not touching
It would
-1.
be y less than -1?
No, greater than. Y is above.
Oh, well, we're not talking about the not touching space, we're talking
Right.
about touching.
The touching space, the range.
Okay.
Right. Otherwise we say, well, y can't be less than -1, but that's too many things. You know what I mean?
Yeah.
Yeah. So the rule with the can't be's is it's just got to be like one number or two numbers. Do everyone kind of follow what I'm saying? Like y can't be 0,
Okay.
right? But once you start getting into a whole group of stuff, it can't be 0 or anything below it. Then it's you should just say what it can be.
Okay.
Okay, cool. Now we're going to go on to our next one, which is super fun. Translations, which we are all super used to at this point.
We're skipping the last one.
Oh, there's a last one? Yeah. Oh, I'm sorry. I'm sorry. My bad. It's the last one. Have people had a chance to look at the last one? So don't worry about that part. Just do this domain and range. And write down what the domain is and what the range is. What's the domain? What's the range? See if I have any asymptotes. I feel like there's an asymptote here. I'm going to draw in what I think is an asymptote. So if I look at the domain, what's the furthest left it goes, what's the furthest right it goes, are there any holes? Are there any spots where it can't be? And then for our range, what's the lowest it goes, what's the highest it goes? I know you done already.
No.
Range is the left-right. Sorry, domain is your left-right. Domain is your x. That's what you start with. Start from, this is my domain, I'm starting from here. So that's your x, that's your input. What's the furthest left it can go? What's the furthest left this thing goes?
Okay.
Negative infinity. What's the furthest right it goes? Positive infinity. Is there anything it can't be? Are there any breaks or any holes in it that you can see? No. Done. How about the range? How would we find the range? The lowest to the highest. What's the lowest it goes? What's the highest it goes? As I go along this path here, what's the lowest I go? What's the highest I go? What's the lowest I go?
2.
The highest I go, this is a 2 here.
2 here.
So it's the highest I go is 2. What's the lowest I go? 1. Can I touch 1? Can I touch 1?
No.
No, so that's going to be a rounded. Can I touch 2?
Yeah.
Yes, so it's going to be square.
Mm.
Does it have a vertical asymptote? Up, down asymptote? No. Does it have a horizontal asymptote? Does it have a horizontal asymptote?
Yes.
Yes.
Yes. What's the horizontal asymptote?
1.
Yes, something equals 1. What equals 1? So pick a spot on here and figure out what's 1 at that spot. So I'm going to pick this spot here. What's 1 at that spot? What's the spot? This is 0, 1. Does everyone see that? So what's 1 at that spot? X or Y? Y. X, Y. Y is 1. That's my the equation for that. Is that everyone following? That's kind of the easiest way of figuring out whether it's X or Y equals.
Oh, so y cannot equal 1?
Mm-hmm.
Oh, y. Thank you.
All right, so let's go ahead and move on. Translation. All right, translation of rational functions. This is the most fun, easiest part. This is you're gonna love this. It's awesome. So here's our basic function. Y equals 1 over x. Right? Y equals 1 over x. That's our basic function. And you'll see this little cross it has here at 0, 0. Everyone see that? Its center is 0, 0. See how it's centered at 0, 0, like most of our things seem to be centered at 0, 0? So it's just, I'm going to draw, first thing I'm going to do when I do these is I'm going to draw my asymptotes through the center, through 0, 0. Boom, boom. And then everything else falls off of there. So from the center, if I go back 1, down 1, that's kind of my starting point. I just draw a line out this way to graph it, and down that way to graph it. Same thing for the other side. I go right 1 and up 1, and I do the same thing there. Draw a line off there and off there. They're super, super, super straightforward. What's the domain? What's my domain of this basic one?
X cannot equal 0.
X cannot equal 0.
And the range.
Natalia, what's my range? Oh, check with your neighbors. Ryan, what's the range?
X can equal 0.
Oh, so that's the domain.
Y can equal 0.
Y can't equal 0. Good? Did that answer people's questions? No? Okay. So those are the lines that can't equal. What are the dashed lines? What do the dashed lines represent? Asymptotes. asymptotes. The lines they can't touch. Right, so those will be x equals 0 and y equals 0. Does everyone kind of follow that part? The lines they can't touch. Since x can't equal 0, x equals 0 is the line it can't touch. Since y can't equal 0, y equals 0 is the line it can't touch. Okay, so now we're going to talk about graphing them. So yeah, we're not gonna worry about graphing them. We're just going to kind of work on. We're not gonna do anything complicated with them. We're just gonna stick with graphing the asymptotes, and then kind of, like I said, kind of pulling it off in each section. So here, I'm gonna translate the basic function. Write 2 units. So here's my basic function. I'm going to translate it right 2 units. So I'm just going to look at the top. So here it is. This is my center. My new center is going to be 2 to the right. Does that make sense for folks? So in pencil, on your one above, I want you to put in the spots where this is your new center. So I'm going to put a big empty circle there because that's what I can't touch. And I'm going to do my little lines in either direction. So your your new center is where the big hole goes that you can't touch. And that's where both of your asymptotes go through. So 2 to the right, big circle, that's where we can't touch. Asymptotes go right through there. Good. Yep. Other direction. Great. I feel like everybody has. Everyone that I saw hasn't, so that seems good. Perfect. Now, this is how I'd recommend you do it. From your new center, there's actually a line I can't see. You're going to go over 1 and up 1. That's a point on the line. And then if I go up 1 more, it's kind of the halfway point here, and sort of the halfway point there. Those are the other pieces that I kind of go through.
How did you get the second one?
So here, this one here, if I go over 1 more to the left, then it's a half. It's kind of 2 over and a half.
Or half up.
And kind of 2 down and a half there. So if I go down 1 more, it's a half over. So this is going to be, so that's these points here. These are kind of the weird points here, these half spots. So as I kind of do this, I kind of try to hit the half spot and I go out to the edge. Try to hit the half spot and I go out to the edge. Does that understand what I'm saying by half? This is halfway between these 2 spots, these lines, halfway between this point and that point, and down 1 more. Halfway between this point and that point, and over 1 more. So this is kind of 1/2, halfway between these 2. This is halfway between these 2. And you kind of hit them out that way. Right, so this is where it is, and as you'll see, we've got our asymptotes. All right, now the function itself, remember, if it's left-right, that's on the inside, right where x is. So it's on the underneath part. If it's up-down, it's on the outside. So here, y equals 1 over x The inside is right inside where X is. And the outside would be out here. You know, adding or subtracting it out here. Does that everyone kind of follow? So this would be this here. How has that been shifted? Is that on the inside or the outside? Everyone look up. Is this on the inside or the outside?
Inside.
Inside? So remember, whenever it's on the inside, we go the opposite. So -2 means what? Left or right?
Right.
Right, so this is going to be right 2. Everybody on board? Good. So that's the one you just graphed. We just shifted it right 2. This would be its, that would be its function of the one we just did, the one you just graphed. It'll have a vertical, X can't be 2, so it'll have a vertical asymptote at X equals 2. Y can't be 0, so we'll have a horizontal asymptote at Y equals 0. All right, here's a second example. Now we're going to translate it. We translated it up 2. So then I start off at my 0, 0 is my regular spot. I go up 2, that's my new hole, right? And I would draw in my cross, my asymptote cross, kind of in a way. And then you have your over 1, up 1, draw those out, back 1, down 1, draw those out. Again, that's how that works. If I go up 2, how's this going to change? Is it going to be up 2? Is it going to be on the inside or the outside?
Outside.
Up, down is on the outside. So I would just add 2 to the end. Good? Everyone understand this? So up 2 would be y equals 1 over x plus 2 on the end. That's my up 2. Okay, quick question. How has this been shifted? Everyone take a look. Talk to your neighbors. How's it been shifted? David? What's my inside shift? What's the inside shift?
Just make it
Plus 3. So remember, inside is going to be the opposite. So plus 3 would be, is that my left, right, or my up, down?
Yeah, that's right.
Left, right. So plus 3 is going to be what? Left or right? Left. Because remember, it's the opposite on the inside. So this is going to be left 3, and then what's my up, down?
Down 2.
Down 2. Minus 2 on the outside. Down 2. So this is left 3, down 2. Here's another one. What's that one? Okay, the red one. What's my left-right shift? What's my shift?
Right one.
Right 1. And then what's my up-down shift? Up 2. Good. Do the next one. What's my left-right shift? Left 2 on the inside, right? And the up-down shift is up 3 on the outside. All right, so, we did that already. So that's it.